Hi everyone, you are watching the Day 2 Piecewise and Step Functions notes video. In this video, we're just going to dive a little bit deeper. We're still going to use the same skills as Day 1, only we're going to interpret some functions that are in context. All right, so let's look at example number 1. The equation to determine the weekly earnings of an employee at the Hamburger Shack is given by W of X, where X is a number of hours worked. So that's important information to me. I'm going to highlight it. Now, all of you stop for a minute because there is a big mistake in this equation. There was a typo. So right now, I'd like for everyone to put plus 400 on the bottom piece. Okay? So part A says determine the difference in salary in dollars. Okay, so we put in hours, we get out dollars if we're thinking about a function. Who works 52 hours. Okay, hang on a second. So if they work 52 hours, that's our X value, right? Our hours is our X. So if our hours is our X value and we're looking for 52, I think we're going to have to use this piece, right? Because isn't 52 bigger than 40? So we'll use our domain to help us. And we're going to compare that to someone who works 38 hours. So if somebody works 38 hours, 38 falls between 0 and 40, so we're going to have to use this piece here. Okay, so we're going to substitute in some values. Let's do the 52 hours first. So 52 has to go into the 15, and this is the X minus 40 piece, plus 400, remember. And then the 38 is going to go into the 10x piece. Okay, so we could do a couple of things here. We could substitute in and do this algebraically. It doesn't say we have to do it algebraically versus graphically, but let's just show it algebra-wise so that way we know what is up. So 15 all times 52 minus 40 plus 400. You can type that right into your calculator, just how you see it. So let's just see, 15. So 15 parentheses 52 minus 40, close those parentheses, plus 400. And that ends up equaling 580. So $580. Sorry, my dog's barking. And then 10 times, in this case, 38. I don't need my calculator for that. That's 380. So if I want to find the difference, that's just 580 minus 380, which is a difference of $200. And some of you are like, why are you doing that again? Well, look at it's asked to find the difference between the two. Okay, now part B, on the other hand, is saying determine the number of hours. So we actually have to find the X value when we're given the Y. Now, there's a couple of ways that we can do this. I think graphing it is best. So take a minute, pause your video, graph this on your calculator. Okay, after you've done that, this is what it should look like. Okay, so I'm now going to push Control T to look at my table of values, and I am looking for $445. Well, already we know that it's going to be more than 38 hours, right? Because of part A. So it's going to be past this, and in this case, it is 43 hours. So 43 hours. How did we do this? Well, I should probably label it 43 hours. I graphed. And found X equals 43 when Y equals 445. Perfect. Okay, number 2. A driver leaves home for a business trip and drives at a constant speed of 60 miles per hour for 2 hours. Okay, so right away at the beginning, if there's 0 time traveled, They're not going anywhere, right? So 0, 0. And they're going to drive at a constant speed of 60 miles per hour. So 60 miles for every hour for 2 hours. So 1 hour, 2 hour that's happening for. Okay, oops, I'm going to connect those with a straight edge. That's constant. And then he gets a flat tire. Oh, her car gets a flat tire, and she spends 30 minutes changing the tire. Okay, so time will go by, but distance sadly will not. So for a half hour, this poor girl is going to be changing her flat tire. She goes back to driving and drives at 30 miles per hour for the remaining 1 hour. Okay, so 30 miles. So in this case, each one of these lines is 60, so 1 is 30 miles every 1 hour. So 30 miles, and then for 1 hour. So it looks like we're going to have to go halvesies because that was 2.5 hours. Okay, so here is a picture of the graph. It doesn't really tell us anything. I guess I'm just going to label it f of x would be my function. We didn't really have to do that because it didn't tell us to. But here is an example of how we can create a piecewise function. And in this case, it kind of connects to one, or it does connect with one another, just to see how you can model real world on a graph.